myself, Dr. Preeti Jagwani. I am an associate professor from Department of Computer Science, Aryabhat College, University of Delhi. So today we are going to begin with one of our new series, lecture series, which is computer networks. So in this lecture we are going to introduce computer networks and we will be looking on to some basics of this. So we as human beings always strive for development, and if you look into the past 3 centuries, they are actually dominated by different technologies, or we can say they are dominated by single new technology. For example, if we talk about 18th century, so in 18th century we all witnessed the industrial revolution and great mechanical systems which are accompanying which were accompanying those industrial revolution things. Then if we talk about moving forward, if we talk about 19th century, the biggest we can say invention there which dominated the whole century was the steam engine. And if we talk about 20th century, so past 3 centuries we are talking about 18th, 19th and 20th. So looking into 20th century, we can see what information gathering, processing and distribution. And among all other developments of this information gathering, processing and distribution, human beings have also witnessed the installation of worldwide telephone networks, invention of radio and television, and we can say birth and also unprecedented growth of computer industry, also launch of communication satellites, and obviously last but not the least is internet. So as a result of this technological progress for 3 centuries which we have just seen, these are the areas which are rapidly kind of we can say in convergence in 21st century. So 18th was different, then 19th was different, 20th was also different. But if we talk about now 21st century, all these areas which have witnessed their inception in the 3 we can say the 3 centuries, they are now witnessing their convergence, and the differences between collecting, transporting, storing, processing information are actually I can say quickly disappearing. So let me give you an example here. There is a very common term which we talk about in our kind of which we use in our daily life, which is ICT. So that is information and communication technology. So here is a kind of we can say a convergence of information and communication. Now if we talk about computer industry, yes, we can say it is still young as compared to the other industries which we talked about, for example let us say automobiles or something of that sort. But on the other hand, computers have made spectacular progress in a very short time, and during the first 2 decades of their existence, computer systems were actually highly centralized and usually confined we can say within a single room. But now as I have told you that information technology has been merged with communications, or I can say the merging of computers and communication has had a profound influence on the way computer systems are organized nowadays. So once a concept was in much of in dominance, which was the term which was termed as computer center. So computer center is we can say in the legacy times, it was a room with a large computer to which users bring their work for processing, maybe kind of some batch processing or something of that sort. That concept or that kind of computer center is now totally obsolete, although we can say yes, there are data centers which are holding thousands of internet server, and this is very common nowadays. But having a large computer within a kind of a huge room is something which is which we count now in legacy systems. So if we talk about old model of a single computer serving all the organizational computation needs, now that has been replaced by the model, or we can say by the entity in which a large number of separate but interconnected computers do the job. Now we are not dependent on one single computer, but we have kind of large number of separate large number of different distinct computers. Although these computers are distinct, but they are interconnected and they are performing some specific task. Now these systems in which you have interconnected computers, not only computers but other devices also, these systems are known as computer networks. So if we want to define computer networks in a very formal way, we can say, let us begin with what actually network is, and then we will boil down to computer networks. So if we talk about the term network, it is nothing but a group of two or more similar things. It could be things, it could be people which are interconnected with each other. So either the similar things are connected with each other, or some people are connected with each other. That entity or that system we call as network. Now if we talk about some of the examples of the networks which are around us and we witness them in our daily lives, is social network. We also have some mobile networks, we also have network of computers. So airlines is a network, so is railways, banks is also a network, they are operating, they are interconnected to each other. Then hospitals have their own networks and so on and so forth. So if you look around yourself, you are, I can say, you are in the web of different networks. So this was actually networks. If we talk about computer networks in a specific manner, so computer network is actually a system where two or more devices, now what all these could be, these devices could be, that we will talk later. So a computer network is a system where two or more devices are linked together to share data, resources and information. And if we talk about these networks, they can range from very simple setups, like for example connecting two devices present at your home, or even the simplest thing which we do in terms of networks is connecting your laptop or connecting your desktop with a hotspot, and you are sharing the data or you are taking the data from the mobile. So that is actually a network of mobile and your computer, two different devices. Now these can be very simple setups. As I was talking about, I have given an example of a simple setup like connecting two devices in your home, connecting a laptop and a mobile and using the mobile data on computer. That is actually a network. Now this can be some very massive global system, and the famous example here is the internet. So internet is also we can say a network, and I have given you an example of hotspot connected to the machine. That is also an example of the network. So these can be very simple setups, or these can be very complex setups. Now as I have told you that we will be talking about devices. Devices as in, as told earlier, that two or more devices are linked together in order to share data, resources and information. So one of the primary goals of establishing a network is sharing. Now what all can be shared? Data can be shared, resources can be shared, information can be shared. Between whom? Between the devices. Now what are those devices? So devices, if we talk about, these devices can be normal computers, these can be high end servers, these can be printers, or any other hardware. Now network, as I have told you, that what is the agenda behind establishing a network, why one should establish a network. So one is kind of sharing, or we can say it is allowing the efficient exchange of data, and through this efficient exchange of data we can enable various applications. So what applications I am talking about? The most common one is email. Email is one application of networks, or we can share some files, or we can browse whatever we want on internet. So all these are applications of we can say networks. Now devices like computers, server, printers and other hardwares are linked together. linked together in order to share data. As I have told you, sending of an email from one location or from one ID to another is sharing of data. Now, if there is a, we can say a common printer and 2 or 3 computers are using that particular printer. So, this is a very common scenario in organizations. So, one floor is having 2 or 3 printers and so many maybe 20, 30, 40, 50 computers are connected to that particular printer. So, this is actually sharing of resources, or it could be kind of sharing of information also. So, these setups, these small setups or these kind of highly complex setups, they allow for exchange of data or kind of exchange of information, or there could be kind of sharing of resources also. Now, one of the most complex network, or we can say a large network which is well known, is network of networks, and that is, I hope you must have guessed by now. So, this network of networks is actually the internet. So, in at the within the internet we have various machines, various computers, various devices which are connected together to make a large network, and this large network is kind of, we can say, internet. Now, when can we say that these two devices are connected, or these two computers are connected? So, two devices or two computers are said to be interconnected if they are able to exchange information. Now, how are they going to exchange information? Only if they are connected to each other. Now, what kind of connection I am talking about? This could be any type of connection, starting from it could be a legacy maybe copper wire, or kind of twisted pair cable, or it could be an advanced fiber optics. So, now all these are all these are media. So, copper wire, twisted pair cable, then fiber optics, is all these three comes under the category of guided media. On the other hand, we can have unguided media. For example, we have microwaves, we have infrared rays, and there can be communication satellites. They can also be used as media in order to exchange the information. So, two devices, when they can exchange the information, when they are able to exchange the information, we call them as interconnected devices. Now, many times your computer network is actually confused with distributed systems. So, these are two very different terms. One is computer networks, another one is distributed systems. So, if we talk about the key distinction between these two, so the key distinction is that in a distributed system, a collection of independent computers appears to its user as a single coherent system. So, users see that kind of we can say that collection, that cluster as a single coherent system, while in that collection there are so many independent computer system. So, and usually it has we can say a single model or a paradigm that is presented to users, and it is presented as one particular unit, and often a layer of software on top of the operating system, and this software layer is known as middleware, is responsible for implementation of this model which is based on kind of a coherence system or a paradigm which appears as a single model. So, a well known example of distributed system is World Wide Web. Now, I am not talking about internet, I am talking about World Wide Web. So, these are two different terms. World Wide Web is different and internet is different. So, distributed system, if we talk about, a well known example of distributed system is World Wide Web. Now, on top of which particular kind of we can say entity it is going to run. So, it runs on the top of internet, and it presents a model in which everything looks like a web page, everything looks like a web document. So, this is I was talking about when we look into the key distinction between computer system and computer networks and distributed systems. So, distributed systems is basically collection of independent computers appearing to the user as if they are kind of a single coherent system, and example of this well known distributed system is World Wide Web. On the other hand, if we talk about computer network, this coherence or this model, or we can say the software, is a software built on top of the network is, or on top of the system is not there. Users are exposed to the actual machines without any attempt being made by the system to make the machines look and act in a coherent system. So, if they are individual units, user can see them as an individual unit because there is no kind of no, we can say, cover on those clusters or on those collection in order to make them, or in order to look them coherent. And in effect, if we talk about a distributed system, we can say is a software system built on top of a network, if we talk about the key distinction between the two. And this is that software which is going to give kind of a high degree of cohesiveness and transparency to that particular system. And the distinction between a network and a distributed system lies within that software, especially we can say operating system rather than the hardware. So, a distributed system is a software system built on top of a network. Now, as I have told you that the agenda basic behind establishing the networks, that will look into all, that we will also look into the evolution or history when we will explore that. So, effectiveness of a data communication system depends on some characteristics. So, actually your computer networks is kind of a data communication system, because we are able to kind of exchange the data, we are able to exchange the information, we are able to communicate. So, basically 4 fundamental characteristics. So, what are these characteristics which are going to be the kind of parameters for the effectiveness of a data communication system. So, first is delivery, next one is accuracy, third one is timeliness, and fourth one is jitter. So, delivery, accuracy, timeliness and jitter. Let us see them one by one. So, if we talk about delivery, the system must deliver data to the correct destination, and data must be received by the intended device or user, and only by that particular device or user. There can be multiples of users which are which can be the intended receivers, but who are the intended receivers? Those must have, and only those must have the data received. So, the system must deliver data to the correct destination, that is delivery. So, if the delivery is correct, that means your data communication system is effective. Then if we talk about accuracy, the system must deliver the data accurately. That means the data, if it is being altered in the transmission and left uncorrected, then it will become kind of unusable. There are possibilities that the data kind of becomes somewhat distorted or somewhat altered during the transmission, but before handling it over to the receiver, we must kind of correct it by using some mechanism. If the data is being altered and left uncorrected, that means that data is unusable. So, in short, we can say the system must deliver the data accurately. Now, next the category, the characteristic, if we talk about, we have seen delivery, we have seen accuracy. Now, next if we talk about is kind of timeliness. So, timeliness says the system must deliver data in a timely manner. For example, data is being delivered kind of very late, that becomes useless. For example, in case of video and audio, if we talk about, Timely delivery is something kind of delivering the data as they are produced in the same order in which they are produced, and that too without significant delay. So that means it should not be like that whatever I am saying is being kind of someone's lips movement are being shown early, and the sound corresponding to those lip movement is coming maybe after a few seconds. So that is we can say data is not delivered in a timely manner. So for timeliness for a system to ensure timeliness, it must ensure that data should be delivered in a timely manner, and these kind of deliveries we can say kind of real time transmission in which we can have audio and video synced together. Now after accuracy and timeliness, we have also seen delivery at the first place, then we have seen accuracy, timeliness. Now we are coming to the jitter. So jitter, if we talk about the technical definition for jitter, is variation in the packet arrival time. Now the question says, what is packet? So at this point of time in the introduction, you can assume that packet kind of is a bundle of data. So jitter refers to the variation in the packet arrival time. It is the uneven delay in the delivery of audio or video packets. So for examples, video packets are sent every 30 milliseconds. So some packets arrive at 30 milliseconds delay, other are arriving at 40 milliseconds delay. So an uneven quality in the video is going to be the result of this kind of procedure. And sometimes you must have seen that videos kind of flickering or something of that sort. So that means there is a variation in the packet arrival time, and that is what we called as jitter. So basically 4 characteristics in order to mention the or in order to measure the effectiveness of a data communication systems are: delivery, timely delivery is required, then accuracy, high accuracy obviously is the need of the hour. Data should be delivered in a timely manner, so timeliness, yes, is important, and finally there should be kind of no jitter, and interconnectivity. This is what we call the 4 fundamental characteristics of an communication systems. Interconnectivity of computing devices in a network allow us to exchange information simultaneously with many parties. This can be done using email, websites are there are so many audio video calls which can be taken in the group. So basically, apart from this exchange of information, network is also there to share the resources, as I have told you. So for example, a printer can be made available to multiple computers through a network, or not only a printer, a networked storage can be accessed by multiple computers. So this networked storage is also an kind of an example of a resource which is being shared with the help of network. And as I have already told you, given this example earlier also, that people often connect their devices through hotspot, and that hotspot is, or that connection is also we can say is a small personal network. So if we look into what we have seen, what we have gone through in this particular lecture, we started with a new topic which is about computer networks. Then we explored the term networks, what is the basic agenda behind coining this term, or what is the basic agenda behind implementation of networks. Then we also looked into the computer networks, what all could be the components of the computer network, how a network is different from a distributed system, because these are the two terms which are often, we can say, confused with each other. So, we have seen a clear line of distinction between a distributed system and a computer networks. And finally, we moved on to the effectiveness of a data communication system, the characteristics of the effectiveness, or kind of, we can say, the measure of effectiveness of a data communication system, which depends on the four fundamental characteristics. So, the four fundamental characteristics which we have seen are delivery, accuracy, timeliness, and jitter, and we have seen all these four characteristics in detail. Here is a kind of list of references which is being used for the preparation of lecture. I hope you have enjoyed this one. I will see you in the next lecture with more about networks. Till then, take care. Goodbye.